In this video, I will discuss some JEE Main PYQs from the topic straight line motion. These questions are based on the equations of motion for 1D, where acceleration is uniform and constant. So the first equation of motion is V equal to U plus AT. U is the initial velocity, velocity at time t equal to 0. A is the acceleration, t is the independent variable, and V is the velocity at any time. And the displacement S is ut plus half a t square. So this equation gives the displacement given time, initial velocity and acceleration. Third equation of motion is v square equal to u square plus 2as. So this gives the velocity at different displacement values. And one important thing to notice is these equations are valid when the acceleration is uniform and constant. So that means the acceleration will be a real number. And for the motion of the body, say thrown from the Earth's surface, this is Earth, and for mass m, thrown up some initial velocity u. So if we take this is the origin and this is the positive direction, then for this particular motion, acceleration is minus g. All this velocity, acceleration, displacement have a direction. For 1D motion, we can take out the direction by using the sign. So if we choose upward direction as positive, downward direction is negative. For 1D motion, there are only two possible directions. One is upwards and one is downwards, or one is towards right and one is towards left. So one direction we choose as positive, the other direction, the opposite direction is negative. So according to this convention, the acceleration here is negative. So based on this, we can solve these questions from JEE Main. This is the first question. You can read it. The helicopter rises from rest on the ground vertically upwards with constant acceleration g. A food packet is dropped from the helicopter when it is at a height h. The time taken by the packet to reach the ground is close to g is acceleration due to gravity. So four options are given. The answer is time for the packet to reach the ground in terms of h and g. You can pause and attempt this question. Say this is the ground level. Okay, the helicopter is here. So this is a helicopter and it rises from rest. So initial velocity of the helicopter is 0. So when this helicopter attains a height h, it will have a particular velocity that we call V helicopter. And when it reaches this height, a packet is released from this helicopter. So a packet comes out. So the initial velocity of the packet that will be equal to the velocity of this helicopter. That's an important point to realize. The packet is dropped from the helicopter. That does not mean the velocity of the initial velocity of the packet is 0. Because the packet is traveling with the helicopter, whatever is the velocity of the helicopter, that will be the initial velocity of this packet. And since this helicopter is moving up, the initial velocity of the packet is also upwards. So the motion of the packet will look like this. From this height, it will go up and it will come down. With this initial velocity, it will go up, but the velocity will keep on decreasing because the Earth's gravity will pull it down. So the velocity will keep on decreasing. The velocity of the packet at this point will be 0. After it will turn back and then hit this ground with the Earth's surface. So you have to find this time, t. So you have to use the equations of motion. First, you have to get this initial velocity of the packet. Once that is known, the time is known. In terms of h, this height is h from here to here. So to get the initial velocity of the packet or the final velocity of this helicopter, we can use this one. V square equal to u square plus 2as. This for the helicopter. Acceleration of the helicopter. Okay. Initial velocity of the helicopter is 0 because starting from rest. So the first term is 0. And let me take the upward direction as positive. You have to choose one direction as positive. I'll choose this as my origin and the upward direction as positive. So according to this convention, the acceleration of the helicopter is plus g because acceleration is moving up upwards with g. So 2g and the displacement of this particular point. I'm applying this equation at this point where the helicopter is at the height h. So s for that particular point is h. So velocity of the helicopter at that height h is square root of 2g h, and this is the initial velocity of the packet. So once you know the initial velocity of the packet, we can get the time taken for this path using s equal to ut plus half a t square. This is for the packet. So let me put p as suffix. And for this motion, I'll choose a different coordinate system. I'll choose this as my origin, and this is my positive direction. So according to this choice of the coordinate axis, at this point the displacement is, so according to this coordinate system, the displacement is minus h because upward direction is positive. The initial velocity is upwards and the value is root 2gh time plus half. Acceleration is downwards minus g because upward direction is positive. And then t square. So this is a quadratic equation which you have to solve to get this time taken for the packet to reach the ground. So this we can rewrite as g by 2 t square minus 2ght minus h equal to 0. So the roots will be minus b, that is square root of 2gh plus or minus square root of b square is 2gh minus 4ac. A is g by 2 and c is minus h divided by 2a. A is actually g by 2, so 2a is g. H. This 2gh minus n will go with this one more to this 4gh plus or minus square root of 2gh by g. So if we take square root of h by g common outside, So it will become root 2 plus 2. So root 2 is 1.414 and then 2 is 2. So it will become 3.414 into square root of h by g. So this matches with option C. So C is the correct answer. C is the correct option. So this is what I explained here. So for this helicopter motion starting from west from the ground, so u is 0 and acceleration is upwards g. It's given in the question. So at this height h, the velocity will be from this equation of motion v squared u equals 2as. It use this initial velocity u and the height displacement when it's at a height h, you have to put the displacement as h comes with the velocity of the helicopter when it's at a height h as plus root 2g because upward direction is positive. So v is plus. So this motion of the packet, the initial velocity of the packet will be same as the velocity of the helicopter when it is dropped. So it will be plus gh, root 2gh. And the acceleration of this packet is due to the gravity, which is downwards, so it's minus g. And the displacement is minus h. If I choose the origin as the displacement axis as the point at which the packet is released. So putting displacement as minus h and initial velocity as root 2h and then a as minus g, we get the quadratic equation in time. So this I can rewrite like this. And roots of the quadratic equation minus p plus or minus square root of b square minus 4ac by 2a. So this you have to manipulate and you get 2 plus root 2. Root 2 is 1.414. So option C is the correct answer. So the important thing to realize in this question is the packet when it's released at height h will not come down straight, it will go up and come down. This is required initial velocity. So let's move on to the next question. A ball is projected vertically upward with initial velocity 15 meter per second at t equal to 0. At t equal to 2 seconds, another ball is projected vertically upwards with same velocity. At t equal to dash seconds, second ball will meet the first ball. G is 10 meter per second square. You can pause and run this question. The ball is projected vertically upwards. So do the ball vertically upwards. U equal to 50 meter per second at t equal to 0. At t equal to 2 seconds, so this is ball number 1. At t equal to 2 seconds, another ball, this is the second ball, is projected with the same velocity. Velocity of the second ball is also same, 50 meter per second. But when t equal to 2 seconds, this ball would have gone to a particular height. So this first ball would have reached here at t equal to 2 seconds. So this will also be going up. Okay, so at some time t, the first ball will go up and come down. and the second ball is going up. So these two will be at the same height. So this time we have to find out. Okay. So the displacement of this first ball, if I call it S1, I can write as ut plus half at square, and a is actually minus g. I'm taking upward direction as positive. For the second ball, the displacement, let me call it S2, is u, but the time for this using the same clock will be t minus 2 plus half acceleration again minus g, and then t square times probably t minus 2 square. There is only one clock. The clock starts t equal to 0 when the first ball is getting projected upwards from the ground. Okay, so if I put at t equal to 2 seconds, the displacement of the second ball should be 0. That is true if I put t as t minus 2. So when they meet, S1 equal to S2. So this time I can find by equating these two. So if I do S1 equal to S2, that means ut minus half g t square equal to u t minus 2 minus half g t minus 2 square. So the value of t which satisfies the equation is the time where the two balls will meet. Because when they meet, both the distances S1 and S2 are same. So this I have to solve. So this will give me 2u here and half g t square minus t minus 2 whole square. Okay, so this I can write as a minus b into a plus b. A minus b is, sorry, a plus b into a minus b. A plus b is 2t minus t into a plus b is, sorry, this is a plus b, a minus b is 2. A plus b is 2t minus 2. A minus b is 2 into g by 2. U is given as 50. So this will become 4 times u by g equal to, another 4 will come here, 4 times t minus 1. So 4 and 4 can get cancelled. And u is 50. So this is 5 equal to t minus 1. So t is 6 SI units seconds. So it's option B. Option B is the correct answer. So u is 50 meter per second upwards. and acceleration that's acting on the ball is downwards because Earth is pulling it down. So the displacement is ut plus half at square and v is minus g. For the first ball, it's u is 50t minus half gt square. For the second ball, it's starting 2 seconds after the first ball. So for this, we have to put the time t as t minus 2. Because at time t equal to 2 seconds, distance the second ball is 0. That will come when you put t as t minus 2. In this equation, put t equal to 2 seconds, s2 is 0. When they meet, both the displacements are same. So if we equate these two and do the simplification, we'll get t as 6 seconds. So at the meeting point, the first ball is coming down and the second ball is going up. This is how they will meet. Let's move to the next question. This is actually a simple question. The ball is thrown vertically upwards with initial velocity of 150 meter per second. The ratio of the velocity after 3 seconds and 5 seconds is x by x plus 1, x plus 1 by x. The ratio of the velocity after 3 and 5 seconds is x plus 1 by x. The value of x is. You can pause and attempt this question. So the ball is thrown vertically upwards with initial velocity u as 150 meter per second. So at 3 seconds, it will be here at t equal to 3 seconds. At 5 seconds, it will be here at t equal to 5 seconds. So here we have to find the velocity at this point. Let me call it v3. And the velocity at this point is v5. And you have to find the ratio. v5 will be less than v3. Here the ratio is v3 by v5. So v3 by v5 will be greater than 1. So x will be a positive number. So equation of motion, if you use v equal to u plus at, I choose this as my positive direction upwards. So it will be u is plus 150. Acceleration is minus g because it's downwards. And t. So if you put t equal to 3 seconds, that is velocity at 3 seconds equal to 150 minus g. G value is 10. So 10 into 3. And velocity at 5 seconds or after 5 seconds is 150 minus 10 into 5. So we will take this ratio. v3 by v5. So we can cancel the 0. So 15 minus 3 divided by 15 minus 5. So 12 by 10, that is 6 by 5. 6 by 5. So if you compare this one, it will be 5 plus 1 by 5. So which means x is 5. So correct option is option 2. X is 5. You have to find the value of x. No. This is what I explained here. Initial velocity u is 150 meter per second and it's upwards. Upward I have taken as positive, so this is positive. And equation of motion v equal to u plus at. A is minus c because upward direction is positive by choice. So we 150 minus 10t. So this t I have to put as 3 seconds and 5 seconds and get the ratio. So velocity at 3 seconds, velocity of 5 seconds is 150 minus 3 seconds is you have to put 3. and at 5 seconds you have to put 5. And this you have to compare with x plus 1 by x. From this you get x as 5.